1. Hello there, I am Abdul Mateen, and this is my Emath 3 assignment. Let's begin. I have used Desmos to help me generate my graph, and this is my hand-drawn graph below. To solve Euler's method to approximate y1 with dy over dx equals to x squared plus 1 over y, we have to select an appropriate step size, being our h here. Alright, we first use the equation to solve the gradient to get y1 minus y0 equals to mx1 minus x0, m being the gradient. Knowing that the differential of an equation of a graph will get you the gradient, we are able to substitute the derivative of y with respect to x into m. Hence, it is replaced with fx0, y0. y1 minus x1 minus x0 is essentially the step size, as you can see here in the graph. So it is replaced with h. We bring over the y0 over to the right hand side, and we get our equation to be yn plus 1 over yn plus 1 equals to yn plus h f xn yn, or as so written down here. Alright, this thus we have managed to solve Euler's method using the formula. We have managed to derive the formula for Euler's method. As you can see in the graph below, we have our tangent, which is our m, and Euler's method is essentially finding the approximation to the graph for the x value for each x and y value. Alright, so using Excel, we are able to solve Euler's method. First, we have our three different step sizes that I have used, 0.1, 0.2, and 0.3. We have our n value, our xn, and yn. So our original value will be when y0 equals to 1. So x equals to 0, y equals to 1. And our x value is essentially the step, having to add the step size to the previous answer. So as you can see here, it's being plus 0.1 for each value. And we're trying to obtain the value when x equals to 1. So when y1. So when x equals to 1, y equals to 1.911375. When h equals to 2, y equals to 1.909. And when h equals to 3, it is 1.814. But then our x value is not 1, so we take the closest number, which is 0.9. So you can see here that the error difference is gradually increasing for each step size as the step size increases. So we can derive that the smaller the step size, the lower or smaller the error difference. To get our error difference is essentially taking our exact value, which is 1.915 minus approximation. And how do we obtain our exact value is using general solution. So to solve using general solution, we bring over our dx and y over to the opposite sides, and we integrate both sides to get our general solution. And we sub in the value for x equals to 0, y equals to 1 to get our constant c, which is half. And this is our particular solution, or written as y squared equals to 2 over 3 y cubed plus 2x plus 1. So given that y1, we're trying to find when x equals to 1, what is the value of y. So we sub in the value, and we obtain 1.915 to 3 decimal places. And hence, we get our actual value. Alright, thank you. This is the end of my presentation.